yeah, that's pretty much the agenda for this hour session. Trying to go a little bit slowly because I think there's still people coming in. But I'll start with the vision, and then I can do a deep dive of our hardware, which I think Chi also talked about it over his keynote. Just by show of hands, how many of you have were there for the keynote earlier this morning? Awesome. So you already know what the whole deal is all about. And then how many of you have tried our hardware before? Awesome, awesome. That's quite a lot. So yeah, so I guess I'll try to move a little bit quickly on the first couple parts, and then we can do a little bit deeper dive into the SDK because I think that's pretty much the new material. So let's start with the vision, right? So during Chi's keynote earlier this morning, he talked about the vision of making mixed reality for everyone, right? So personally, I would like to break that vision into 3 different parts. First is comfort and usability. Second is connectivity, and third is utility. I'm going to delve a little bit deeper into each one of those, and then we can talk a little bit about how our current product is realizing that kind of vision. First, we start with the comfort and usability, right? So for since our mission is to build mixed reality for everyone, we want this experience to be very accessible, both on the hardware level, also on the user interaction level. So that's why we want the device to be very, very comfortable to wear, as well as very, very easy to use. And I would like to break that into a little bit deeper. To start with wearing experience, there's a lot to talk about with wearing a device, and how that experience can be perfected. But to start with, I want to start with the weight. Our glasses is called Nreal Light, right? So our philosophy is that when you are putting a device on people's head, the device has to be very lightweight for them to wear for extended period of time. Because a lot of our competitors' product out there in the market, they weigh over 300 grams, which I don't think is a good way to let people to actually wear the device for quite a long time. So so for that, we do want to keep the device lightweight enough. And also on the wearing experience side, we really learn a hard lesson that there's quite a bit of a difference across different facial ergonomics. How can we design the best device that will fit everybody's face, that will fit everybody's head, to ensure a good wearing experience of a device like this is a very, very crucial part. So that's basically what this wearing experience contains. And also, I also mentioned usability, right? So that's more on the user interaction level. What we believe is that for mixed reality platform, so this is a new challenge, right? So for the first time, people are actually interacting in 3-dimensional rather than in 2-dimensional, right? Because traditionally, if you're looking at a touch screen, that's 2-dimensional. And with the touchscreen technology, it can guarantee both efficiency and accuracy. But we need to still figure something out for this new medium and to ensure both accuracy and efficiency. So what we believe in is a multi-model interaction method. Different use cases requires different level of accuracy and efficiency. I don't think there's one single method that can satisfy all those requirements. But instead, we can leverage multi-model interaction methods such as voice interaction, gesture control, or even image recognition, or controllers, be it 3DoF or 6DoF controllers, to cater to different use cases. To my second point under the mission is really about connectivity. And this really comes into twofold. One is connectivity to existing platform, and also connectivity wirelessly to a cloud. So this is one of the slides from Chi's keynote as well. So really emphasizing on the aspect of our glasses being compatible across different devices and platforms. So with this hardware architecture is trying to show our glasses being tethered to a smartphone. Because in this way, we are basically leveraging what everybody has already have in their pocket, rather than replacing it with a similar unit. This is our notion of making this product more accessible to everybody, to offer a more accessible mixed reality experience. And on the wireless end, do want to emphasize a little bit on the 5G front. So I think a lot of speakers over this event, Chi from our company and also Hugo, Prince from Qualcomm, do emphasize on the future of 5G and how 5G is impacting mixed reality community. There are a couple of different ways how 5G is going to revolutionize the mixed reality experience. I think one of the most talk about way is doing remote rendering or split rendering, depending on which term you're going to use. There's going to be a distributed intelligence up in the cloud, and what the edge is trying to do is, the glasses is trying to send a 6-off pose up to the cloud and have the cloud to do the rendering and then send the rendered image back down to the glasses. That's a very promising way to leverage the power of a cloud computation and empower an edge device like a glasses. That's obviously the future that we're trying to go after. Right now, we're still tethered to a host device, but as Hugo mentioned over his keynote earlier today, we're actually moving towards a 5G connected wireless connection model for this type of product. And also, 5G can also extend the use case of mixed reality as well. A lot of people talk about holographic teleportation. We actually did a demo last year in a private room doing holographic teleportation, and that is going to, with 5G, the latency, the bandwidth, that's actually going to be really, really, really helpful. And the third point is really about utility. So we do believe mixed reality is the next platform. It should be penetrated to a rate closer to 60 to 70% eventually. But in order to do that, we need to find the killer app, the use case for this type of technology. And to start with, it's really about the content ecosystem, right? So when you are purchasing a hardware platform, as a consumer, you do expect that there are content running on top of it, right? Oftentimes in the field of AR and VR, there's been a chicken and egg problem. You don't really have a good device to start with to develop content on, and you don't have good content to drive the sales of devices. So the content developers are not really making money from this ecosystem. So we do realize there's a chicken and egg problem for this part, and I'm gonna share momentarily how we're gonna break this down into. So actually, this slide is the key that we're trying to show. So the way we are seeing the content is actually being tiered into 3 major layers. One is actually on the mobile. One is actually in the middle, which is the immersive mixed reality applications. Of course, we're gonna develop that because that's basically what's unique and what's native to mixed reality platform. But also, we do want to leverage the existing platforms already, right? So everybody has their phone. So Apple and Google has been launching AirCore and AirKit in the past couple of years. So the portability of mobile AR applications is also another important factor because those existing content is, we should be able to leverage that instead of, just completely ignoring it. Last but not least, the previous platform, which we call is the smartphone, right? Those are there are already native Android applications or content running on smartphones already. So in mixed reality platform, we should be able to figure out a way to first leverage those content, and second, figure out a way to add additional value on top of it. And the way we're adding additional value is through multitask, right? Mixed reality, one of the great advantage of mixed reality is you really have a boundaryless view or a screen to start with, right? So oftentimes on a 2D or on your smartphone, you are often constrained by the boundaries of the screen, of the touch screen, right? So let's say, for example, if you're playing a game, right, through the screen, you can only see as much as the phone offers, and oftentimes it's pretty limited. But as compared to augmented reality or mixed reality devices, for example, our device, the field of view is 52 degrees. That translates to almost a little bit over 100 inches, 120 inches TV placed 2 meters away from you. So with that broader range of view, you'll be able to place multiple windows of content all together simultaneously. And that does empower you with the ability to multitask. Last but not least, One additional way that this platform, I personally believe this is the most interesting way, is through artificial intelligence. Mixed reality glasses like ours, nreal Lite, it does have two features. One, it actually has a lot of sensors on board. There are cameras, microphones, all different types of sensors on board. And second, it's really portable. Our device is really lightweight. If people can wear it for an extended period of time, then over that time, the device can collect information out of the people's life, and based on those information, through the connectivity and all the kind of infrastructure I just talked about, the data can actually train a distributed intelligence up on the cloud to make the cloud even smarter and smarter, and that's actually the way to move artificial intelligence a little bit forward. So to talk a little bit more concretely, where we see this technology is trying to go is based on these 4 use cases. Of course, it's going to start with gaming, right? Because with virtual reality technologies, what you see with a lot of existing products is first people use it to play games, and second people use it to watch videos. So of course we see augmented reality is still going to bear the same use cases for gaming and also for social, right? So I talk about a holographic teleportation in a sense that you don't have to it really transcend the locational gap between two people and really let you meet in a different form. We do believe that mixed reality have the power to revolutionize social in a different way. Education. So I think in the education industry, people have been searching for methods to actually make learning a little bit more interactive. And mixed reality does empower people to actually do this, because with multimodal interactions and 3D display systems, you do get a more intuitive sense of what you're learning. You can visualize models in a different way, and you can interact with the model in a completely new way with the more intuitive interaction methods. Last but not least, productivity. So the notion behind this is the following. So a lot of companies like Adobe or Autodesk, when they're trying to empower designers, oftentimes they encounter the barrier that those use cases cannot be transferred to a mobile platform. The reason being, first, mobile platform only has a limited display, and second, the interaction on the mobile is not accurate with regard to 3D content creation. So with mixed reality smart glasses like ours, we believe there's a potential that, first you're seeing a broader range and also in a 3D format, and also, the platform can be compatible to more intuitive interaction methods, and that will create a great increase in productivity. So yeah, that's pretty much a little bit dissect of the vision that Shi shared earlier over his keynote, and also I'm going to do a little bit deep dive for those of you who haven't got a chance to try our product yet. So and also to answer some of your questions. So this is the nreal Lite that I've been constantly talking about. It's called light by 2 meanings, right? By the first meaning is really lightweight. The glasses only weighs 88 grams. We try to make it a little bit, just weigh a little bit over one normal pair of glasses, because this is a weight we believe that will be comfortable for people to actually wear. Back to the notion of making mixed reality accessible to everyone. And also it's portable. So with this new design, we do have the capability of folded temple so that you can take it anywhere. And also we want to keep the design to be very sleek, so that everybody can be comfortable wearing the devices, not only in a personal setting, but also also in a public setting. And these are the color selections that will be available in the upcoming months. Speaking of the optical system, because I know a lot of you in the industry has been paying attention to the optical part. So we do have a 52 degrees FOV diagonally. The aspect ratio is 16:9. And also, to the previous slide, the image quality is often undermined in this field, and we believe we do still have the best visual quality. I think Shi did a comparison to two of our competitor products. And as you can see, you can, with his slide earlier today, with our device, you can really read text, but with others, you can see fuzzy edges on the text. Last but not least, there's one important factor that we do want to emphasize. Our device, let me show you this one. So our device, there's a cable coming out from the left temple that has a USB Type-C port. This port can be plugged into any USB Type-C full function port and give you the cross-platform capability. So it can be a smartphone, it can be a PC, it can also be our own computing unit, which also runs on Android platform. This is something that we have not really talked about before, but to give you some more information of how this whole architecture works, basically, the glasses itself contains a whole bunch of sensors, and the sensor data is being passed down through the cable to a computing unit. What the computing unit does is it basically, first provides the power of the glasses, and second, process those sensor data and provide rendering images upward to the glasses. And also, a lot of you have been asking about, what's that little disk do? It's basically a 3DOF controller that can be connected to the computer unit via Bluetooth Low Energy. And that actually contains 3DOF tracking as well. Another combination, which is the phone, and that will completely replace the computing unit as well as the controller. To talk a little bit more specifically about the sensors on board, we do have dual monochrome cameras, one on each side. On the middle, there's a 5 megapixel RGB camera for photo taking, video shooting, artificial intelligence. On the display, the resolution is 1080p, which I believe is still the highest among all AR glasses. We do have dual speakers on board that support spatial audio, powered by DTS. And also on the left temple I just talked about, there's a USB Type-C cable coming out from the left temple. On the computing pack, is powered by Snapdragon 845, and also on the it contains a battery which will last for 4 to 5 hours of active use. And on the top, there's 3 pins for automatic pairing between the puck and the controller. All right. That concludes my part, and then I'm going to pass it on to Wei to talk a little bit about the SDK. Thank you.
Hello? Oh, yeah. OK, great. So hi, I'm Wei, and I'm very excited to be here to introduce nreal SDK. So nreal SDK is a platform for building MR apps. And so one thing is that it has a set of very powerful and advanced MR features. But at the same time, we make it super easy to use. And with very simplified developing process and using high-level APIs, you can achieve very awesome MR features. And also, the most important thing is that it's cross-platform. So we can look at the software architecture of the nreal. So you can see, as Zhihao mentioned before, so the application can not only run on the nreal box PC, but also can run on the Android mobile phones. So there are currently about 2 billion of active Android mobile phones out there. And so we're rolling out to support all of them. So by the end of this year, maybe there will be around 6 million devices can be compatible with nreal glasses. And also we're across Android and Windows operating system. And nreal SDK is a very open platform, so we actually welcome all the third-party services and SDKs to join us to build a whole ecosystem. And now we are supporting many of the most popular developing environments, including Unity and the native C APIs. They are all available right now. And nreal is coming later this year. And also with all these capabilities, you can build MR applications, either it's an entirely new experience or you can enhance an existing native Android app by adding some MR features on it. So no matter you are an experienced MR developer or you are new to MR, our mission is to empower you to create great MR apps and to help you to reach all your users. So if you are a experienced developer, maybe you know that, for example, the HoloLens and Magic Leap, because of their price point and their limitation on production, so it's not really available and accessible for both the developers and the users. But as for the nreal, so for the developer, if you have your Android phone and with just no more than $500 US, you can get AR glasses, and just with 2 of this, you can start developing something. And to the users as well. And so because there's no limitation on what kind of electronic devices they are using, they can have a PC or a mobile phone, or they have our computing box. They can all be the potential audience of your content. So I think it's not only a great opportunity for us, but it's also a great opportunity for all the developers that want to join the whole ecosystem. So I'm going to share this roadmap with all of you. And so everything showing here, I promise, is going to happen. So yeah. So what you can do right now, from today, is that you can go to our official website and sign up for the applications for the developer kit. And you can also join the community right now. We have a Slack channel, and the link is on our website as well. And for our SDK beta version, together with the documentations and tutorial and all the resources that you need to learn about our SDK, will be released in the mid of July. And our SDK standard version will come out in August. And during this time, so we love to hear as many as feedbacks from all the developers. So if you have any ideas about or anything you think we need to improve, just don't hesitate to let us know. And in September, we're going to ship out the first wave of our developer kits. So I'm going to share with you guys a trick that how can you be the first one to get our developer kit. But I'm going to share this trick at the end of this talk, so please do stay here. And you'll find it's really worth it. And so this is from the September this year is just the beginning. So we will keep upgrade and iterate our SDK into adding on more and more powerful features. For example, meshings and the LED estimate and tracking, which we're currently not supporting, but we're going to definitely support it in the future. So if you're a developer, you can simply write us an email, say, hey, this is the content that I want to build, this kind of applications that I want to create, but your SDK currently not support this kind of features. Can you make it possible for me? Actually, we can. So we really care about our seed users, which is our developers. So now we can get started with the fundamental concept of the nreal SDK. So there are 6 parts. So the first one is spatial computing, then it's rendering, interactions, utility, and artificial intelligence. Sorry, so there are 5 of them. I'm a really bad at math. So we can start with the most important thing, which is spatial computing. So nreal glasses has a variety of sensors and cameras which can build sophisticated understanding of the environments and also the user themselves. So with this kind of functionality, so the applications building on the nreal SDK can achieve a truly MR experience, which means the digital contents and the physical space can be seamlessly blended together. So these 3 features are available right now, so they will be fully supported in the beta version. So now we take a look at the 6 stuff tracking. So it's also known as SLAM, or some other companies call it world tracking. So basically, there are two SLAM, or we can say spatial computing cameras on the both sides of the nreal glasses. And so it can identify the feature points in the environments and track the movement of these points over the time. And with the combination of this movement and with the combination of the movement and the readings from the IMU sensors, which are located in the middle of the glasses, and we can do long linear optimizations. And with these optimizations, the accuracy of the tracking will be improved. And also the 6-stop tracking not only can provide the developers and users with a very accurate tracking of the positions and orientations relative to the world, but it also can provide with mapping and 3-point cloud informations. So with this, the applications can have an understanding of the physical structures in the environments. So now we take a look at the plant detection. So now in our beta version, we support not only horizontal but also vertical plant detection. And also as the cameras move in the environment, so the plan can be updated and the plan can be extended as well. And if there are multiple plans are detected at the same time, so they can merge into one when they start overlapping. And the third one is image tracking. So, so this function enables the applications to respond to the pre-trained images in the environment. And also, the images can be, the image's position and orientation and physical size will be updated during the session. And also, multiple images can be detected and tracked simultaneously, which means if you are a developer, you can have a set of the reference images. And nreal SDK will tell you where they are in the physical space. So let's look at the rendering. So actually, we have done a lot of work for rendering because in the case of MR, the users are very sensitive to the latency. So the latency can cause the sickness and dizziness, make the users very, very uncomfortable. So we have to do a lot of work backsync, and we won't talk too details here because all the features here is automatically applied to the applications. So as a developer, you really don't need to do anything. You don't need to enable it or tune it. It's just everything is automatic. But I will just share just one single thing we have done for the latency is time warping. So as you may all know, instead of using the head pose at the very beginning of each frame, we are using a predicted pose, the latest predicted pose at the time of the vsync. So we use this, the latest predicted head pose to warp the image and to do the reprojection. So the whole system latency can be reduced in this way, and also they will solve the missed frame problems, and so there. If you have tried our product, you will see there's almost like no jitter. So then we'll look at the interactions. So our idea is that we want to make the interactions very intuitive and convenient, and also we can give users and developers a lot of choices. So here I'm going to introduce nreal controller and also the mobile phone serve as a controller. So why we came up with the idea about the mobile phone as a controller is that everybody is carrying their mobile phone every day. And so I think it's just very easy to just use your mobile phone as a 3DoF controller. So let's take a look at the nreal controller. So this is a 3DoF controller. And all the states, like the accelerometers, gyroscope, rotation, touchpad buttons, and battery levels, all this state and data are available for developers and your applications. So you can get these states by NR input, which is a prefab that we created in Unity. And now you can take a look at the mobile phone as a controller. So this is actually a default layout that we design for the MR apps, but actually the entire layout can be customized for the specific applications you are developing. For example, if you are developing a game, like a first-person shooting game, probably you want the users to hold the phone horizontally, and there will just be two buttons, one on the left and one on the right. But this default layout is actually suitable for like most of the MR apps. So the upper area, which is a customized area for the developers where you can put some buttons there. And the lower part is a touchpad and support gestures, which all the interactions happens here is mirroring the interactions on the Unreal controller. And at the lower right corner, there is an input keyboard, so where you can open up the keyboard. So as you may all know, like it's always a pinpoint in the mixed MR experience that the user wants to do the text input, except for you use the voice control. So there is not a good solution. But in this way, if you can use your mobile phone as the keyboard, so it's much more user-friendly. And now we take a look at the utility. This is something we made special for the developer. So I don't know what you guys are thinking, but when I'm developing MR apps, and I'm always curious about one thing, it's like where my users are focusing at and what really interests them. Sometimes they keep focusing at one part of the things, but they're just totally ignore the other part. So we build the tools that can collect the gaze data and make it visualize in a heat map. So you can know what actually interests your users. So this kind of like 3D app analytics tool, we think can help developers to know better about their users and finally improve their MR apps performance. So now we can take a look at artificial intelligence, just as Zhihao mentioned before. Actually, we're a very, very open platform, so we welcome all the third parties, SDK and services to join us. And for example, we will be happy to open our RGB cameras raw data and for the developers to run their face detection algorithms. And you can also use the audio data collecting from the microphone to do the voice control and interactions. So I'll quickly show you guys how to develop apps with Unreal SDK. So now we can, I quickly demonstrate like how to creating your first Unreal app in Unity. So we can take a look at this overall structure of the Unreal SDK. So the most important class here is the NR session. And NR session is the object that automatically handles all the things related to the AR algorithms. And so the AR session manager can create and launch and manage the NR session. And the NR session is connected to two things. One is the NR-HMD post tracker, and the other one is NR input. The NR-HMD post tracker is used to update the head pose, and the NR input is used to update the controller. And so there is another class that we defined, which is NR trackables. So anything that can be detected and tracked can be a trackables. For example, images and plans and maybe more things in the future, for example, like faces or 3D objects. So the NR trackable manager can update the transform of the NR trackables during the session. So what's the relationships between the NR session and the NR trackables is that the NR trackables will be automatically created and detected during the session. But if you want to have the access to them, you can use the get trackables method. And so for each NR trackables, you can create an anchor for it. And so these two things are binded to each other. And so their positions and orientations will be updated at the same time. And also on the NR anchor, you can instantiate a Unity game object. And the Unity's game object will, the transform will get the update from the NR anchor. So yeah, like the NR anchor can update the transform of the Unity game object. So I'm going to show you how you can create a very simple Hollow Air demo with Unity. And so the first thing you need to do is to start a session. So to make this very easy, so we create NR camera rig prefab. And within this prefab, there are two scripts. So one, as I mentioned before, is the NR-HMD pose tracker. It's used to update your head pose. And the other one is the NR session behavior, which is a very simple script to manage your NR session. And you can create, enable, disable, and destroy the session. And the second thing, let's take a look at the plan detection. So the first step you need to do is that you need to define a detected plan prefab. And the second thing is that you can use the get trackable method to get the detected plan. And also by using the trackable query filter new, you can get the detected plan in the latest or the newest frame. And now by creating an anchor on the plan, and also you can instantiate the detected plan prefab that we defined earlier, you can make this detected plan visible. And third, if you wanted to place an object with an Unreal controller on this detected plan, what you're going to do is first find the laser origins coming out from the NR controller. And you can do a Unity recast and to find the intersection between the laser and the detected plan. And at the intersection, you can instantiate a Unity game object. And you can also modify the rotation so that the object face to the camera. And finally, you can append this object to the intersection anchor, so it will correspond to a position in the real space. So it's actually very simple. So then I'll show you how little effort is required to migrate an existing app from others SDK to Unreal. So now here we are going to use AR Core as an example, but actually you can also migrate apps built by ARKit or HoloLens or Magic Leap. There's just so AR Core here is just one example. So let's compare how Unreal and AR Core manage the session. So you can see they're basically they looks very similar. And the only difference is that the Unreal used the AR session manager to manage the session, but in AR Core, they use the lifecycle manager. And now we take a look at the plan detection. So for the plan detection, Unreal and AR Core also use follow very similar logic. So we both define a detected plan prefab, and we use the get trackable method to get the detected plan, and we instantiate the detected plan prefab to make the plan visible. But coming to the how you can place an object on the plan, there is a little bit different. But except for that, the way that you find the intersections is different. The other process is also very similar, because the Unreal, you are using the controller laser and to find the intersections, but in the AR Core, you use the heat test, which you touch the touch screen to find the intersections. So you can see actually the migrating, the whole process is very simple. So our whole idea is we want to make everything as simple as possible, and everything it can set as automatic, we set it as automatic, and we want to make this migrating process really quickly and easy. And here is one more thing that I would like to share is now Unreal is fully compatible with all the native Android app. So for example, if you have developed a 2D Android app before, so as long as your users have installed this app on their phone, they can simply tap it and run this app in their real space. So from the developer side, you really don't need to change anything. But if you want to make this experience more 3D or more immersive, you can add on some MR features by using Unreal SDK. This is for the users end, it's like a multitasking user cases that Zhihao mentioned before. So okay, so this is almost the end of the talk. So I promise that I'm going to share you with the trick. So here is the trick. So now if you take out your phone and you type this address into your browser, which is www.unreal.ai/developer, and just by taking a few steps, you can become an Unreal developer in a minute. So, but what's the benefit? I'll show you guys now. So today we announced a Project Eve campaign. So because we want to looking for the developers that are very as passionate as we are about the MR. So no matter you are a big team like tens of people, or you are just individual developers, and we want to see what kind of good ideas you have. So please do tell us a little bit more about yourself, your stories or your background, and what kind of good ideas you got. And so the reason why we want to know this is because we want to give you the fully support. We want to make your dream come true. So what kind of things you want to build, we want to support you. So by being part of the Unreal developers, and so you can apply for this developer kit, which is available in September. And so within the developer kit, there's the Unreal glasses, the 3DOF controller, and also the computing unit. And the price is $11.99, which is compared to other MR products, I think this is a very amazing price point. But guess what? If we think you really got good ideas and we think you really is the right one to working together with us to build the whole ecosystem, we'll be able to not only guarantee you will be the first one, the first wave to get the developer kit, and we can offer it to you free. So, okay, so the last thing is that don't forget to join the community. So we have this Slack channel available right now. You can find the link on our website. And so you can find us there anytime. So, okay, I'll leave some time for the Q&A session. Thank you.